Okay, so lesson 4, I know we did 1 and 2. We're going to skip 3 for right now because 4 makes sense first. I'm going to switch them for next year. So we've done the distributive property, okay? We've been doing it in equations and inequalities. Just a quick little refresher here. Remember what the distributive property means. It means distribute with multiplication. So your 4 times your A is your 4A, and then your 4 times your 6 is your 24, okay? They get a little bit more complicated. That's about as easy as it gets. Don't forget, distributing a fraction just means you have to know your fractions in terms of what to multiply. Distributing a half is really easy because multiplying or taking half of something just means dividing it by 2. So a negative divided by a positive is a negative, and half of 6 is 3. Negative divided or times negative, is a positive, and what's half of 20? 10. So don't get confused on that. Another thing to keep in mind is when there's no number on the outside and just a negative sign, it kind of means take the opposite of that whole expression. So it just means go in and change everything. That A was positive, now it's negative. That 13 was positive, now it's negative. Okay, another thing that you might see that's new is distributing from behind. And what property holds true for multiplication when the order doesn't matter? We just learned that. I could switch these 2 around, but because what property is true of multiplication and addition begins with the C, commutative. Good. So that just means distribute it from this way. Okay? When we start to distribute variables, I want you to think about that. This is where we're going to get into some notes separately. So you know that let's talk about like terms. You know that you can't add unlike terms, right? So if I have an x plus a y, it's not possible. You can't do that. But if I had an x times a y, that's very possible. You don't need to have like terms. Multiplication is way less strict than addition. So what is x times y? It's just xy. Okay? So what if I had x plus x? Are those like terms? Yes. 1x plus 2x, or plus another x, gives me 2 x's, right? But what if I wanted to do x times x? And this is where it's going to come into play a little bit on today's assignment, just for one real quick thing. Do you guys remember the rules of exponents? What did we just do for bell work today? If the base is the same, you keep the base and add the exponents, right? So know this. X plus x is 2x, but x times x is x squared. Okay? Got to just remember that. Do you remember last year doing like 3x squared times 5x cubed? So you multiply the 3 times the 5, which is 15. This is chapter 8. And then keep the base, which is an x, and add the exponents. Okay, if you remember that, great. You're going to see it for like 1 in here. So if I have 4a times a minus 7, if I were to distribute a 4a times a, thank you, what do you think 4a times a would be? Sophia. Good. 4a squared, because 1 plus 1 is 2. And then 4a times negative 7 is obviously just negative 28a. Okay? You're going to see that. So just kind of look out for that. Yeah, that's all you really need to know. Then you're going to get into some that have some combining and distributing. What do I distribute here? Good. The negative sign. I like that she didn't say the 3x because I'm distributing, and a lot of times I'll have kids just kind of box it out. So the 3x is kind of hanging out, waiting to be combined with whatever the product of this is, or the opposite, rather, of this is. So this is negative 7x and a positive 5, and now I combine my like terms to negative 4x, positive 5 as a constant. Okay, and we've done this in equations, right? So that's why this is kind of just a quick review. Let's look at this one. What if I did a times b? And the reason I kind of went off on a tangent here is because somebody said you can't. But you can. You can't add them. You can multiply them. So what's a times b? And then what's a times c? Okay? So this problem is going to help you understand this side. When you look at ab plus ac, what term or variable do you see that they both have in common? An a. So what I need you to know is that when you distribute, you multiply a number through, and when you factor, you take that number out. Okay, Joseph, pay attention. And you go backwards. You undo the distributive property. That's what factor means. So if I started you off with the AB plus AC and said, what did I start out with? And what did I distribute? You see an A in both of them? That's why the A is in front. And then the B plus C is what was left after you pulled that A out of there. Do you understand? Okay, so everybody watch up here. Let's look at it with this. Let's say I have a 4A plus 24. It's not as obvious as them both being an A, but what do both 4 and 24 have in common? They have a 2 in common, right? But what are we always looking for? The GCF, right? So 2 isn't the biggest common factor, but what is? 4. So do you see why that's there? The 4 is what pulled out. And now, how do you get the A plus 6? I'm going to give you 2 options. Are you ready for this? So write this somewhere. 4A plus 24. First, you're going to recognize what number is the common factor. Pull it out in front or behind if you want. It's up to you. And the first way is to look at and say, well, if I were to distribute this 4 back in, what number would need to be right here for me to get 4A? A. Okay, and that's kind of like the easiest way to look at it. What number would need to be right here that when I multiplied it by 4, I got 24? 6. So I put a plus 6, right? That's the first way. That's called looking at it as multiplication instead of division. Another way is to just say, well, what I just did is I divided that 24 by 4. And this times this gives you that. Which, guess what? What did we just do for lesson 2? Didn't we just divide that expression? So you could look at it as, oh, those cancel, and I'm left with A plus 6. So that's your other factor that would go in. Do you understand? So if I start out with let's say, what's another problem? If I take 4x minus 10, what number do they both have in common this time? 2. A 2. So I'm going to pull that 2 out. And what expression would I need to multiply by 2 to get 4x minus 10? A 2x minus 5, right? Because I said 2, the only thing that's going to give me that is if that's a 2x, and then 2 times 5 is 10. Or look at it as that, and doesn't that give you 2x minus 5? However you want to do it. Okay, what if I said 3x squared minus 33? What number do they both have in common? And what's left? An x squared minus 11. All right, let's take this one step further, and let's put an x on the 33. So now they have more than just a 3 in common. They have what else in common? Yes, an x. I like that you didn't say x squared. Because, listen, I have to be able to pull the same amount out of both. Yeah, this one can give me 2 x's, but this one can only give me 1. So the only thing they have in common is that. What goes here? What would I have to multiply by to give me that x squared? An x, and what goes here? 11. So does everybody agree that 3x times x minus 11 is that? Yes. Okay? So, taking a look at this, you have to be able to distribute this through and then go backwards and pull it out, which is called factoring. So, we're going to say that this is due Thursday. Today is Tuesday, which means you don't have to do this today. Okay? You're going to have a short homework assignment today from the actual assignment. So this is due Thursday with a quiz on these 4 on Thursday. Okay? Slot quiz. Everybody good with that? Okay. Moving on to solving compound inequalities. Some people think this is fun. They like doing this, but okay. So if I were to When I talk about compound inequalities, first thing I talk about is compound sentences. Remember back to when you were like in first grade and you had to write a paragraph and it had to have 5 sentences. Weren't all of your sentences, I like gymnastics, I like math, I like to play, I like to swim, right? So as a writing teacher trying to get kids in first and second grade to expand their horizons, they introduced something called conjunctions, which are connector words. So do you remember what a compound sentence is? Do you know what a compound word is? It's like sidewalk, right? Chalkboard. It's 2 words that make 1 word. So a compound sentence is 2 sentences that make 1 sentence. And what was the most common word you used as a connector? And, okay? Guess what? That's what we're going to use today too in math to combine our inequalities. Another one was or, right? So do you like chocolate or vanilla? I like chocolate and vanilla. So, okay, I'm asking you to go back and think about that. So we're going to do the same thing with inequalities that we did back in first grade with our sentences and combine them, okay? So the first thing I'm going to ask you to think about is, before I even write it, if I were to say, hey, give me a number that's greater than 5, at first you start to think 6, 7, 8, 9, 10, right? But then I say, and that number also has to be less than 8. So I'll say it again. Give me a number that's greater than 5 and less than 8. Give you a minute to think about it. How many numbers whole numbers only, because I know there's an infinite number. How many numbers would fit in my solution set? How many numbers are greater than 5 and less than 8? 2, right? And they are what? 6 and 7. So let's put some symbols to that. First thing I would do is say, I asked you for those numbers, right? Okay, so everybody's writing these. And the next thing I said was give me these numbers. Okay? Well, if we're thinking back to I like to swim, I like vanilla, well, let's combine those. This is what we're going to do. We're going to combine it. So the first thing you see is that they both have an N, and that's kind of a wasted ink, right? So we're only going to write the N once. Okay? And it's going to be smack dab in the middle. And now I want you to look at 5 and 8, and I want you to think about their placement compared to each other on a number line. Which one's to the left of which? 5 belongs to the left of 8 on a number line, right? So that's the most important thing is I want you to put those numbers there. And I left spaces here because I have to fill them in with inequalities. And the first thing I do is look at, well, one of them's already pretty simple, right? If the N and the 8 are both there, don't I just bring that sign down? Okay? So I'm going to keep this like that. But the only thing that's going to be a little different and new is that N is greater than 5, which means 5 is less than N. Okay? And I want you to remember it by this. Where was the little nose pointing? To the 5. It needs to stay to the 5. Okay? So what we just did is we turned 2 separate inequalities into a compound inequality. And I need you to understand how to read that. And in order for you to understand how to read it, I needed you to create it with me. So do you understand where this came from? It came from me taking these 2, and the only thing different is I had to remember to switch that one around. All right? Here's how you're going to be asked to read it. To read it, you're going to say 5 is less than N, which is less than 8. Okay? So let's write that. So to read this, you would say 5 is less than N, which means N is greater than 5, right? Which is, meaning the N is, 5 is less than N, comma, which is less than 8. Okay, does that make sense? All right. So the only other 2 things left we have to do is tell me what those numbers would look like on a list and on a number line. Okay? And we did this back when we did 6-1. So, tell me all the numbers that N could be. You told me that N could be what? 6 and 7. And guess what? Do we put a dot, dot, dot? No, because this time it doesn't go on and on forever. Your solution set has 2 numbers, and that's it. Okay. Number line is where this really, really comes into play, so you're going to want to watch this. First thing you're going to do, remember how when I had to have you do n greater than 5? You know what? You got to put them both on the number line now. Don't forget to put them where they're supposed to be in relation to each other. You don't need 0. Put your circles. Decide if you're going to color your circles in. So can it be 5 in my solution set? No. Can it be 8 in my solution set? No. And now I'm going to show you 2 different ways to graph them. And you're going to have to decide which one you're more comfortable with. I'm just going to go back to this and graph n is greater than 5. Now I'm going to graph n is less than 8. Okay? So what you're looking at, looks like a little car. When you're looking at this, then the and is going to be where the overlap is. So see what I mean by overlap? Okay, is there overlap here? No. Is there overlap here? No. So there's only overlap, and I know there's a bunch of numbers in between, but because we're counting just the whole numbers, there's only overlap at 6 and 7 for our listing purposes. We know 5.5 is also a solution, right? And 8 and 7.5 and so on. Okay, that's the way you may want to do that, but guess what? You will not see 2 arrows in the book. You know what you're going to see in the book? You're going to see a 5, an 8. You're going to see this. See the difference? Okay, do you see how they're similar though? Here they just show you the overlap. They don't show you where this one all went and where this one all went. So you have to be comfortable with knowing that this is a result of graphing 2 of them separately. Are you good with that? Well, I think this one helps you kind of understand what I mean by overlap. This one you don't see overlap, you just see that. So you won't see this in the book. They're going to ask you to read these. So I want you to get comfortable with these. So using that way to help you. So let's do this. Let's see if you can take this and figure out and walk me through the whole thing. Now, I didn't start you out with them as 2 separate. They're just written like that. Hey, guess what? If it makes you feel more comfortable and you want to write them out separately, you go right ahead. You could say x is less than 2, and x is, what would I write? If it's greater than or equal to -3. And now that you have that, here's my question. Do you want to do your list first or your number line first? Whatever you think helps you better. Some people may want to graph it first, and then their solution is obvious. Some people may want to just think about it. So let's put our number line out. -3 is to the left of 2. Put your circles. Are you going to color one of them in? Yes. Which one? Because that gets colored in. Can include -3. Where are the numbers on this number line greater than -3? To the right. Where are the numbers on this number line less than 2? To the left. Where is your overlap? And then I need you to tell me exactly what those numbers are. So in this one, your solution set could be what? What do you think those numbers could be? I'll give you a minute to think about it. What's the first number that can be included, Nasser, in my solution? -3. And then what? -2, -1, 0, 1. Can 2 be included in it? No. No dot, dot, dot. I have 1, 2, 3, 4, 5 numbers in my solution set. Are you good with that? Okay? So your graph for that you will see in the book will say -3, 2. It'll be colored in here and open here. Okay? Like a little barbell or something. Okay, now what if I were to walk up to you in the hallway and say, hey, give me a number that's greater than 5 and less than 2. Oh, and by the way, I'll give you $1 million if you could think of one. Give me a number that's greater than 5. So right now you're thinking 6, 7, 8, 9, 10. Oh, and the same number has to be less than 2. Yeah. Right. Okay? I thought you were going to give me a number. So what she said is there is no number that is greater than 5 and less than 2. So what would that look like on a graph? If and means I'm looking for overlap, I want you to think about this. First of all, let's write the 2 down. I want x greater than 5, and I also want it less than 2. So the first thing you're thinking of is here's 2, here's 5, here's my circles. What direction does this arrow go? Greater than 5 means to the right. Less than 2 means to the left. And I don't know about you, but I don't see any overlap. Right? So, no overlap means you got a big O, 0 with the line through it. And I want to talk about what that means. That is the symbol for the words empty set. Okay? Empty set does not mean it's undefined. So if your answer is undefined, you can't put that symbol. Okay? So this equals empty set. Which means, it's kind of like the silliest thing you could think of, which means all of your x values can't be any. When you see that, it just means you have a set of numbers that doesn't have any numbers in it. Is that kind of silly? So it's kind of the same as basically like a no solution, okay? So no overlap. So understand what that means. Good? All right, so I would like you to try this one. -4 is less than or equal to a, less than or equal to 0. So try to list it for me. Tell me all the numbers and graph it. Can it be -4? Yeah? How do I know? Because of that right there. Color it in. Can it be 0? So both -4 and 0 are going to be included in my number line. So basically it's going to be -4 and 0 and every number in between. So greater than, you have to know that you're going less than 0, but greater than 4, which means basically you're going to have this area right here. So now that could mean -4, -3, -2, -1, and 0. Everybody good with that? No, A is less than or equal to 0. Because you got to read it from that. So A is less than 0, but A is greater than or equal to -4. Okay, everybody good on that? Hi, how are you? What you got? Oh, thank you. You must have done some cleaning, huh?
I was. The gas men were out there all day. So.
Yes, how funny. Thank you. I appreciate it. All right, cool. No, they know they're not. Thank you. Okay, so now we have the ands covered. Let's talk about or. All right? Or, the first thing you need to know about or is that it cannot be written in the combined format. Cannot. I need you to write this. Be written combined, like we did before. So if I were to say, give me a number either greater than 6 or less than 2. Well, how many numbers can you think of that would fit that? Yeah. Yes, your answers are infinite. Because if I say, give me a number greater than 6, you instantly start thinking 7, 8, 9, and forever and ever and ever. Okay, you know what? If you don't like those, Just give me a number less than 2. Oh, okay. 1, 0, and so on, and forever in that direction. So I want you to picture this. X is greater than 6, and then it's going to have a big or in the middle of it, and X is less than 2, or, okay? On a graph, what would that look like? Here's your 2, here's your 6. So if you decide to give me a number greater than 6, you can give me all the numbers in this direction. Or if you don't want to choose that set, then let's go and give me one less than 2. So guess what? It kind of looks like the empty set for the and, doesn't it? Okay? So now, if I were to say to you, list all the numbers that X can be, you would be like, I can't, because they are infinite. I want you to think about this. Sometimes is it easier to tell me what numbers your solution can't be? According to this, give me all the numbers that X can't be. Sophia. Yep. It can't be 2, 3, 4, 5, or 6. If it's anything but those, you're good. Do you understand that? So your solution set can include things, but you gotta make sure you're telling me that those are the numbers that X cannot be. Okay? Everybody understand that? And then, so obviously then if I colored that in, I would have to take that off the can't be set because then it's in the can set. All right, how about this one? X is less than -1 or X is greater than 0. Try that. And then you decide which way is best to tell me what my solutions can be or can't be. What's the best way, do you think, to write this solution? What numbers can X be? All numbers greater than 0 or all the numbers less than -1? Which means the only two numbers that X cannot be is -1 and 0. Whoops. Right? So what would happen, do you think, if I colored them both in? Then your solution would be, yes, technically, yes, because if we're talking about the little infinite ones, the rational numbers in between, if we're talking about whole numbers, all numbers could be. Okay, very good. All right, I need you then, one last thing to be able to do. If you are given a verbal sentence, I need you to create the inequality from it. I need you to write an inequality that represents all real numbers that are greater than -2 and less than 3. So because it's an and, I need to see it written like this. Don't write the and separately. The ands have to be written as combined. Okay? So write it combined. And then for today's homework, you're going to do the list and your graph for all 8. I'm giving you 1 through 8 all today. Yeah. The list is when you have to do, tell me either what it can or can't be. Okay? So, if you want to start as writing them two separately, is that what you guys did? And then combine it? That's up to you. Give me greater than -2. Well, that's greater than -2. And less than 3. And then you go ahead and you write it combined. X. -2 is to the left. 3 is to the right. This goes here, and this goes here. And then you graph and list from there. Does everybody understand? Okay, you are doing page, I just wrote it down, 384, numbers 1 through 8 all, and you got to do the graph and the list. If you don't have the graph and the list tomorrow, you're going to not get your 5 out of 5. Okay?